Rob Probin with remote force. Are you ready, Rob?
I am ready. I am ready, Peter. What a hard act to follow. So, okay. So I'll just share one of my screens. So I'm sure that some of you guys have come across this before. Some of my topics on 4th 2020 apparently are about maybe how to debug or how to visualize things or how to make things simpler. Get to the, what's the simplest route. Um, so this presentation is about that with a tiny bit of a demo, hopefully. So I get involved as a outside of our day job I get involved in just random general interest in things, right? If you're going to do something in your spare time, then it better be interesting. And one of the things I've sort of been involved in is retro computer development, right? And one of the things specifically, I had as a kid, I had a Sinclair Spectrum, UK computer, 8-bit computer based on the Z80, and there's been quite a lot. I guess it might be a bit due to the age now. I mean, everybody that owned a computer in the 80s maybe has got some spare cash, so there's lots of retro computer scene happening at the moment. And specifically, I've got an interest in Forth. It's a great thing to play with. So that obviously these two things come together. So I've been looking at sort of how to make this so that the development cycle's shorter, right? But I think this particular topic's got applicability to other things. As some of you know, I'm involved in small robotics. And some of you have probably already touched this before, but we'll see. So I'll start with the computer. This computer is a modern remake with extra things. It's got a Z80 based core, although it's implemented on FPGA, and it emulates a bunch of the Sinclair Spectrum and Amstrad machines, and also other things. I mean, they've got a QL core for it now, Sinclair QL core for it, and it's a standalone computer. It's got its own keyboard. And so I've been playing with this, and there's a whole bunch of programming options. Mostly these relate to, obviously you can use basic and extended versions of the basic within the 80s. Z80 assembler, I wrote a lot of Z80 assembler in the 80s and beyond, apparently. Forth, obviously, there was quite a lot of force for these types of machines, as a lot of you know. Even Sinclair Spectrum, I don't know how many it was, maybe 5 different Forths or something. I didn't really get on a massive amount with Forth in the 80s. Really, I learned more about it in the 90s. There are also cross compilers for C to get and BASIC, although having looked at the Z80 is really not a great target for C. I always look at the output of C compilers and just cry when they're converting it to Z80. But one of the compilers I've been involved with recently, which and the authors on the call, Matteo, is VForth, right? So VForth's sort of and he's Matteo's been working on this VForth for years, but he's done a version of VForth for the Spectrum Next, and it's got a bunch of stuff. It's a really cool thing. It's got a full PDF manual. There's additional information on the wiki. It's got file support. It's got screens. It's got graphics. Supports all the. I mean, it's a really nice environment for this machine, and it operates on the machine right now. So if you're developing for this as a modern person, right? So if you're developing for this machine from C or from BASIC, or compile BASIC, you might develop on your own computer and then download either to the actual machine or to an emulator on that machine, because there's a couple of emulators that emulate the machine. But I want to develop on the machine, right? So, but I'm still using my main computer to develop some of the code. So how do we lower the gap between the machine? And I can flick over to, maybe I'll just switch over to show you this. So this is the actual machine. As I mentioned before the talk start, this is captured on a Ugreen HDMI capture. This machine's actually got VGA, which gives perfect timing, and HDMI as well. The developers of the FPGA included HDMI, so you can put it on modern televisions. So this is the actual machine, and this is Matteo's V4. And I can do, you can do the normal things like, add numbers together. If I can operate the different keyboard, that sort of stuff, right? So it's a full development environment, and you can edit files on this. It's got screens and files. So he's included a line-based screen editor and a full screen editor and a file editor on the development machine. So that's pretty good. So this goes back to this, right? So, and you can also use the CLI, so you can type things in and figure out what's actually happening. But obviously, some of the time you want to be on on Visual Studio Code, and you want to have all the amenities of your normal machine. So there are Spectrum Next emulators that I can run, and a lot of them have got development facilities, so you can load stuff in them, but it's still not quite the machine. You can also move these things. Have got SD cards now, so you can just unplug the SD card, write files on it, plug it back in. Most of my working life apparently has been about reducing the amount of time it takes me to write the code and debug it or get it actually what's it called. And to give you an idea, one of the big projects I was working on, the embedded projects for the intrusion industry, burglar alarms, was 1.4 million lines of code, and on a multi-core machine took 20 minutes to compile the C++ framework and another 20 minutes to compile the application. When you were doing the whole thing, obviously, you didn't want to affect a header file that was including a lot of files, right? It's just insanely ridiculous developing that slow, right? Whereas obviously I want to be able to load the code and interact with it almost straight away. So moving SD cards is just insane. There is a pretty cool program called NextSync, right? Somebody's written a program that runs on the Spectrum Next, and there's a program that runs on the PC that looks like this, right? So you've got on the right hand side, you've got some files on your computer that you've been editing with Visual Studio Code or whatever your favorite editor is. I also like Vi and lots of other ones. And then you've got this program running on your computer that's basically sitting there waiting for a connection. And the Spectrum Next on the left hand side, you run a program on it, and it fetches it does a synchronize. It's a bit like rsync on Linux, right? It synchronizes a bunch of files across into the Spectrum Next SD card, and the Spectrum Next has actually got an ESP01, or it's an 8266 module on it, and the Z80 talks to that over a UART, right? This works really well. You just type sync and it pulls all the files across in a few seconds. So I was like, well, this is pretty cool. And this was the way I was sort of developing half of the time, right? But it's still a bit, it loses the interactivity. And as a lot of I mean, this is sort of like an embedded target, right? And a lot of people on the call are doing embedded development. And you want some sort of command line that you can go from your main machine and just access it, as we have been doing with Forth forever, right? So this is sort of the project that I'm sort of halfway along. So this is this remote terminal, right? Same sort of thing. Be able to actually run the words remotely and maybe even stop the program. So if I've got, for instance, say if I'm developing an 1980s style computer game on the Spectrum Next, I might want to drop into the middle of it and just pause the program and go and investigate what the hell it's doing internally, right? So be able to drop in a word into your Forth code and be able to, establish a remote session wherever you are in the program. So there's two concepts I was working on. This is the one I started with, which was the same as sort of Spectrum Next. You've got this sort of program that's acting as a dual port serial server, and then some sort of serial terminal, your favorite serial terminal, maybe connects that dual port server, either via a sort of COM port or via some sort of telnet based program. And a lot of serial programs now don't just connect over serial. They've also got obviously PuTTY and others, call term, Teraterm. They also can connect over a raw TCP socket. And then you have a fourth word that connects via the ISP01. And these this ESP01, usually you don't reprogram it. Obviously, it's a general purpose Wi-Fi microprocessor, and you can write your own. I mean, there's even ports for it, right? But the standard code that's on this machine is just the standard. There's a sort of demo type program that loads of people use, including in industry and real commercial products. That's just got AT commands, as you would on a Hayes modem for anybody who remembers those. I'm not old enough, honestly. So it's got AT commands to be able to connect to this dual port server. So you could take a fourth word like remote, and it talk to the ESP and establish a connection over to the dual port server, and then you'd have your this is sort of acting as a sort of bi-directional jump off point or a redirection server in web. So this was concept number one. I started developing on this, but you end up with this program in the middle that you're doing a lot of development work on. So this is concept number two. So this ESP01, as well as establishing outgoing TCP or UDP connections, you can also listen for connections as you would with a normal computer, maybe in if you're writing a bit of a server, right, in Linux or Unix. And you can just listen for a connection on it, and then it when a client connection, you tell it how many clients you want to connect. So this is what I'm playing with now, and I hope to be further along. When I agreed with Peter to do this talk, I hope to be further along. But I'm working on too many side projects at the same time. But I guess I thought I'd give you a demo of where you are, because I think this is sort of, especially involved in embedded systems. It's sort of a useful thing, and I'll talk a bit about. I'll talk in a minute a bit about what the alternatives are and why I think this might be good, not just for if you're playing with Spectrum Next, but if you're doing any sort of embedded development and you want some sort of connection. So let me just show you what some of this ESP stuff looks like. Now, so I need to figure out which what's it called. So I'm now back in my fourth session, and I've preloaded screen 12. Now, when I talked originally, Matteo's a great guy. You can just ping him on Facebook or ping him on the GitHub, and he's great and responsive. And he says, I do a load of work on my computer with files, but I tend to actually use screens. And I was like, well, I've used screens a load of time before, but we've got file support. Turns out that because of the limitations of the machine, screens actually work quite well. So, and you'll all recognize these commands from before. So if I just do a list of screen 12, right? This is screen 12. So I'm loading this remote directory. I'm including this file ESP-UART, right? So ESP-UART is a file I'm not going to show you, but it basically extends that Matteo had done some work. This Spectrum Next has also got a Raspberry Pi Zero in it. They call it an accelerator, right? They don't use it for a lot. Most of the stuff's done on the Z80. So he'd done some examples of talking over the UART to the Raspberry Pi Zero. You can just switch to UART to talk to the ESP instead, which is what this file's doing. So I include this file, and all the established stuff that I've debugged gets moved into a file, which I think is the way Matteo works. And then we call ESP init, which just initialize the UART to the ESP. And then this arrow at the bottom loads the next screen. I'm sure that most people have seen similar things. So let me just list screen 13. So this is my working file, right? I'm actually on screen 14 now. I should move some of this stuff back into the what's it called. So needs, I need the within. That's not included by standard. I put a marker in so I can erase back to this point. It's like forget, but it handles you've got multiple areas of memory. So a lot of ports, more modern ports are like this, where you need a marker, a more effective thing for forgetting stuff. And then lines 3 and 4 I stole from Peter Chikaki, right? So Peter's on the call. I just stole these from his code, from his Tachyon fourth when he was what's it called? Because, why invent stuff yourself, right? So these are just for printing words. So if I go 255.b, just printing in hex. Now I could switch into hex mode, but there's a reason why I don't do this directly, because I've got this. I'm trying to do. I want to have something to print what's sent back to me on the ESP just for development purposes. So I've got this safe emit But, and if I'll show you this, right? So if I go, now I think .esp, so .esp, which is on line 11, basically reads the bytes out of the UART, and there's a hardware buffer in the FPGA from the UART. So there's nothing in it at the moment. So if I do AT, so AT is on line 12. So AT sends AT to the ESP, and I think this is actually in the fourth. So this two ESP line just pushes stuff to the UART, right? So you don't need to know how that works. So I do AT. Now this doesn't print anything because you just sending stuff. So I do .esp. So this prints the first OK. The OK in capitals is what comes back from the ESP01. And this is the standard. So Expressive themselves give this demo code both for the ESP8266 and for the more modern, obviously ESP32 that some of the people on the call know about. So this OK is what comes back when you type AT. There's actually terminal programs that I can link on the Spectrum Next. And I've got boards like this. So that's boards like this with a ESP01 and a USB serial adapter that I can plug into my local computer, but I've sort of moved on to this. So let me do something a bit more interesting than that. So there's this command on line 14. It's ATGMR. So this does line 13. Actually, right. Let's do this. So ATGMR. If I can type it correctly. So run that and then .esp. So this prints out. Plus GMR prints out the version and of this AT program. So this is the program that's running on the ESP01. So you got the version. This particular version was compiled by AI Thinker. So people have taken the expressive code and built their own or built their own version often. So that's that. And I've actually got a word that does that and prints it. So this so you see now this is sort of .esp does the pretty printing. So what actually comes back on the UART is the AT plus GMR gets echoed. Then you've got carriage return line feed, you'll notice in curly braces. So this allows me to look at what I want to see is actually what characters are sent back if they're non-ASCII characters. Then you've got the lines, right? And I can do something else. So .ip actually runs, and you can see this on line 15 at the top of the screen. It runs .cifsr, and that must stand for something, right? The Expressive have got this very detailed document about all the AT commands. So this it sends that command to the ESP, waits 100 milliseconds, and then prints it. So there you go. So this prints. So this is connected to my Wi-Fi network at the moment. So that's a local IP address, and that's the MAC of the ESP01. So it's connected to my local network, and I've got on line 15, and I won't demo it today, but I've got some more commands that I'm working on at the moment. So, oh no, not on that page, not on that screen. Line 14, yeah. So there's some more commands about. So this is to set up these commands 6, 7, 8, and 9. This is to set up the ESP01 to listen for connections, right? And there's a couple of things you can do with these ESP01s. You can put it into transparent mode, which is a bit like the old Hayes modems, where when you did ATD, I remember from the back in the early 90s, and then you put a phone number in, it would connect until you did plus plus plus. So you get so there is a native mode, but there's also another mode which is basically it'll give you can still in command mode, but it'll give you the text on independent lines for everything that's coming in, and you can there's a separate command to send stuff out, right? So you've got more control of the session. So this would, when a TCP session connects to it, it'll send whatever comes in, and you can send stuff to that command. So this is what I'm working. So let me switch back to the presentation. Now you've sort of got a flavor of this, and none of this is particularly complicated, right? It's maybe a tiny bit more work than perhaps a standard serial connection to set up, but it's not terrible. So let me talk about why I think this is more generally interesting. So this is my son's drag race robot that's running in that's actually running Flash Forth. It's an Arduino or an Arduino Nano that's at the top of the screen, and it's running Flash Forth. I don't think the Flash Forth author's on the call today. I think he was last time. And this runs Forth, and it's got this module at the top is a HC06 module. So these have been used. These are, I mean, they're relatively old now, and they're Bluetooth Classic, and it's a serial port protocol. Right now, I've got a load of these, and I use them on various robots, and they're simple when they work, right? Which means that sometimes you get HC05 and HC6, and you can't get it to connect, or it loses connection, and you have to figure out how to get it working again. And when they're working, they're great. It's just a transparent serial connection. But when they don't, it's tricky. The other problem you get with them is if you've got an iPhone or an iPad, right, with iOS, those don't support. They support Bluetooth Classic, but they don't support that particular profile. So that's what driven a lot of the adoption of Bluetooth LE. So Bluetooth LE, as some of you know, was originally it's actually a separate. It's based on the same underlying encoding, but it's actually a totally different protocol, Bluetooth Low Energy, and it was designed for low energy sensors. Right, that was the original. So they've got effectively these attributes which are like sort of like shared variables, and you get notified when they change, and it's really designed for very low power sensor nodes. But obviously people, specifically because they're supported on iOS or an iPhone, there's been a massive proliferation of these devices. So people like Nordic and others emulate a serial port using these attributes, right? It's probably the most efficient use of technology ever. But the problem with Bluetooth LE is they work great on Android and iOS, but and you can get the similar modules. They've got some pins that you plug into a computer, but on Linux, Windows, and Mac, they're a bit tricky to get working reliably. And generally they work great on phones. So you end up with this. What we're actually doing is creating some sort of network between 2 points with really what's a non-networking protocol. So my argument is that in exactly the same way I'm doing this retro computer, you can actually do something similar. It's slightly more complicated, but something similar with Wi-Fi right now. So as well as the Spectrum Next and getting a command line to that retro computer, and obviously out of the back of the ESP01 is just a UART interface, a raw UART interface. You haven't got USB to deal with. I know some of the guys like Travis who write Zepto Forth has ported a fourth USB stack to the Raspberry Pi Pico, but writing it's not my idea of fun, writing USB stacks. So they're very similar devices. They actually supply this AT command language. You can load it into ESP32, which is very popular with a load of people in Forth 2020. And you can get a Wi-Fi connection. So there's some advantages, right? Wi-Fi's got a load of bandwidth, right? It's got you can obviously operate multiple sessions at the same time doing things like you can have a logging session, and you can also have a terminal interaction or more than one terminal interaction session without doing the multiplexing you'd require on the serial interfaces. You have got the problem that you need to get these 2 pieces of equipment connected, right? So obviously if you're in the office or at home, everybody's got a Wi-Fi access point. You can just convince both your computer and you can pre-program an ESP network for the ESP to connect with, and it'll remember that network. I've got that and then so that's. But if you're out and about, so I go to robot competitions. If you're out and about, how do you manage to get a connection when you're not in your office or your home? And there's a few options on this page. You can take a local. They do portable routers, Wi-Fi access points. You can set this ESP01 into access point mode, but that means your computer loses internet, right? Because it's either connected to the access point on your robot that hasn't got any internet, or you connect to to the sort of local internet. You can put your phone into hotspot mode. Well, you can put your phone into hotspot mode, and that's quite interesting. So you can put this in a hotspot mode, and you can get the robot to connect to that and your laptop to connect to it, and that works quite well actually, because you can actually gain. It's not obvious, right? Not only does your robot potentially get internet access, but you can. It sets. They're both on a local IP address generally, and you can talk between one and the other, right? That works quite well. I've used that with robots. You can do things like ad hoc networking, although if you look up Wi-Fi ad hoc networking, it's totally possible. It's a bit tricky, right? You could also potentially do device to device. So you could plug, an ESP01 into your laptop and get a second Wi-Fi connection that way. So there's ways around it, but it is a bit more complicated. And I think that is the end of my presentation. So in summary, I'm working on this remote connection to this retro computer using ESP01. And I think getting access to this, having a good connectivity to either a robot or retro computer is really, really important. And I think it aligns well with the Forth philosophy. I mean, even when I'm talking to people who don't program Forth, I'm like, you need to get, usually I'm like, you're writing all your code in C or C++, you need some sort of interface where you can poke the program to figure out what it's doing. But obviously it comes native with Forth. Okay, so I'll stop there and ask any questions.
This is pretty good. I think I'm doing something similar on my computer on the Bandit. But I'm using an ESP32, so
Yeah.
I'm writing. I have to write the drivers on using C, but it's pretty good what you're doing.
Yeah, yeah. Thank you.
Rob, this is Rich. I like what you're doing here. If I go back to the old days when we were working on the S-Star project for the Navy, we were working on remote RTX 2000 boards, right? And so we were running CM Forth, which is a resonant Forth.
Mm-hmm.
And what we ended up writing was what we call a talker, which ran on, we were using Polyforth on the PC. So you'd start the talker, and depending on what button you press, like say you pressed a function key, the talker would capture that and execute whatever that was locally. But on the other hand, if you were just typing, what you typed went over to CM Forth, and then whatever CM Forth sent back, you just saw. So that kind of transparency and seamless interactivity is always what separated Forth from the other conventional languages when it came to working on on an embedded system. The C folks went to the point of actually figuring out how to run Linux on a tiny little machine so that they could get a fraction of that same transparency. So anyway, I like what you're doing. Keep at it.
Yeah. I mean, so in my day job, we run we're both deeply embedded microcontrollers. Some of the programs are megabytes, even though they're microcontrollers, although some of them are smaller. And then we've got a bunch of Linux products as well. And Linux is great, right? If you can afford the power budget and the although that's dropping over time, and you can afford the cost of the memory, although that's dropping over time, it's now maybe a few dollars to put this stuff in. Linux is great because you can SSH in, and you can, over the SSH connection, you can do file transfers, and you can do, multiple remote terminals, and it's a really flexible paradigm. It's just with Forth, you can do it with 16K micro or an 8K micro, right? And this is a sort of that sort of interactivity is, I think, something that's critical to rapid development and exploration of the whole problem space. So which is why I always think it's a bit like the web cartoon called XKCD, right? He always, ex-NASA guy, he always says, I don't know how long he worked at NASA, but he's got a table in one of his cartoons, one of his thousands of cartoons, which is how long it takes you to do the optimization versus how much it will save you. And it's quite an interesting table because it quite often, you can spend a day and save yourself like a week or a month or several months over the course of a project. And this is this sort of, you stand back and you go, hang on a minute, everything is just too complicated or taking too long. How do I optimize this process on more efficient? And this, in my opinion, this is why I keep coming back to how do I make myself more efficient and get access to the real machine and so I can do things quicker. Thank you very much. Peter is still with us, or I know Peter was in and out at this meeting.
He had to step out for lunch.
Right. Let me just share the agenda then. So I think this should work. Hopefully, maybe. So let's take what time is it? So let's take maybe what do you think, Cornelius? 15-minute coffee break?
It is now, where's the time on this thing? It's now, let's meet at the top of the hour. That's 15 minutes from now, 5 minutes from now.
Obviously, everybody's feel free to talk. If you don't need coffee or a comfort break, then feel free to talk.
Rob.
Okay, so
I'm speechless, Rob. You did very well.
Thank you very much, Matteo. Most complimentary.
Did you try interrupts?
So no. So with the stuff that I'm doing, I've got a computer game I'm writing for the Spectrum Next, Matteo, and this is what's caused this. I mean, I talked to you about it a few, maybe a month or two back.
I remember.
And so so I don't really want to interfere too much because the game engine is going to be using maybe interrupts and the screen, and it might be using some of the memory management units. So the easiest way, I agree, Matteo, is to use interrupts and a load of the memory. But because I use this to debug my game, I'm trying to make it as low impact as possible.
Yes, I agree. Better.
Yeah. So because I'm writing this computer game, and that's what I'm in on this retro computer, I'm trying to make it so that it doesn't interfere with anything. So when you stop in the remote terminal, you've got access to the full machine, you've got access to the full screen. You can interrogate what's happening. You can execute maybe update sprites or pictures or whatever you need to do, and have some sort of full interactivity, full control of the machine, but still with a fourth environment. So hence I haven't touched interrupts or anything like that. But I think that the UART is actually, the UART buffer is quite big on the Spectrum Next, I noticed.
I have to give a look to your work because I think that we are almost there.
Yeah, agreed.
It just miss where you put the inbound characters and trigger the interpretation. Just don't.
Yeah. So I mean, you'd mentioned, I think on Facebook on your fourth group that we could use block 0 that's not used by the screen system.
Yes.
And maybe feed the interpreted line into block 0 without flushing it because the buffer already exists.
I think that using a conventional block, is the best route to go.
Yeah.
And then invoke the standard load.
Yeah.
The tricky part is where to stop, because I think that if you give control to the remote terminal, that maybe there is no way back to the Spectrum keyboard, but I don't know.
So I was thinking, just have I'll just have a word in V4 that exits you from this remote word and disconnects. I mean, the break key was one of them. Obviously, you got this question mark terminal word, so that the loop that's reading lines from the ESP01 from the remote terminal there can be either you can hit the break key on the Spectrum Next keyboard to get out of that mode, or you can have a word that you just execute like a remote exit or something, right? And that remote exit will set a flag on the V4 side that the loop will just terminate the loop and go back into the native mode. So I don't think any of that is particularly difficult. I did look at pad, because I think pad exists just above the dictionary here, stack. I did look at, there's another one as well, I think. No, but maybe not pad. There's two buffers that are sort of, I don't know. Pad is one of them, and then what's the other one? There's another one as well, but maybe block 0 is the other one, right? Anyway, I mean, this is all. Yeah.
Pad is much is narrow. Pad is too narrow, I think.
Yeah. So there's another buffer as well. What was
buffer
another?
Is half
Yeah.
kilobyte. So is the best part. The best place is okay. Let's talk later. Okay, thank you.
Yeah, sure, Matteo. I don't know whether everybody's
Is
interested.
it the terminal input buffer?
Oh yes, that was it. Yes,
yes, Tib is there.
Yeah, Tib is 80
the
characters, maybe, Matteo.
I know. I think is 128.
Is it okay?
Something more than 80.
I don't think there's a constant in this.
It's too narrow too. The best way is to go through load via using a buffer.
Yeah.
Buffer a block.
Yeah, because they already exist, these buffers anyway. Yeah, I think you got seven buffers cached in RAM already in V4.
Yes, there are 7.
And
I use 7. Yeah, I don't know why.
Yeah. I mean, in obviously in the Z80 direct memory mapped memory where it's careful, but obviously in the blocked, in the banked pages, in the 8K bank pages, there's plenty of memory in the Spectrum Next.
Yes. Okay. You can download up to 8 kilobyte in one chunk, but it's tricky. It's a little tricky. The easiest way is to do with a block, with a buffer, half a kilobyte. I think it's enough to send.
Yeah, definitely. I mean, we're only talking about
line,
yes, exactly. We're only talking about a line.
A line, but
but even maybe I don't. But anyway, I'm not overly worried about that.
No.
So my main thing was setting up the ESP01 to do what I wanted to do. I think I think you've got enough tools in V4 to be able to make the rest of it easy.
Yes. I'm amazed that what you done, but I understand. Okay.
Yeah.